So here's part 2 of Lewis structures. So the last one I showed you a pretty basic one with all single bonds. This one's a little bit more involved, not too much more. Just make sure you keep them clean. Make sure all your single dots have buddies that they've bonded with. Make sure your single dots become the line. Don't draw the single dots and the line in the middle. Keep it clean, and don't forget your double dots. So those are some of the rules that I went over at the end of the last video. We'll do another couple examples here. And really the best way to do this is to practice. So give this one a shot even before I do it. And then if you get stuck, watch me do it in the video here. Because if you don't do it on your own, you're not going to figure out where you're getting stuck. And I think the best way to learn is to get stuck and then watch a little bit, just enough to get unstuck, and see how far you can go until you get stuck again. Hopefully eventually you start doing these without getting stuck at all. That's the ultimate goal. So let's start here. First thing we got to do is come up with the magic number. I can't spell magic apparently. I try to go MG. Now nitrogen has, if you look on your periodic table, remember on the top it has 5 valence electrons. There are 2 of them, so 5 times 2. There's 2 nitrogens. So each nitrogen has 5, that's why I go 5 times 2. Chlorine, there are 7 valence electrons in chlorine, times the 2 that are here. And then fluorine is also 7 times 2. So 5 times 2 is 10, 14, 14. 10 plus 14 plus 14, 28, 38. So my magic number is 38. Perfect. Another trick, your magic number will always be an even number. It will never be odd. So if you get an odd number like 37, it is wrong. So that's just little tricks to know that you did something wrong, so you can fix it and make sure you don't get it wrong on the test. Now, the next thing, I'm going to quick draw the structures 1, 2, 3, 4, 5 of each one. Cl is 1, 2, 3, 4, 5, 6, 7. That's a single dot there, double, there we go. And then fluorine looks very similar. Oh, my marker is not working here. Let's just put fluorine over here. 1, 2, 3, 4, 5, 6, 7. So nitrogen likes to form 1, 2, 3 bonds. So I'll put a little 3, 1 bond, and 1 bond. So you always start with the one that forms the most bonds. I've got 2 of them. So I would actually put both of those in the middle. I would go like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now remember, these double dots on top are not going to bond. They just sit there. And anytime you have something that forms like 3 or 4 bonds, like nitrogen or carbon, first thing I would do is just string them together. If you've got more than one, put them together, because odds are they will be. I can almost guarantee it. Now if you look, that leaves me with 1, 2, 3, 4 single dots that are left between these 2 nitrogens. And you'll notice I've actually got 4 things here left. They each like to form 1 bond. So at this point, you could probably visualize that I'm going to have a chlorine, chlorine, fluorine, fluorine. You can put 2 chlorines on this side, 2 fluorines on this side, that's fine. Or if you like to keep it symmetric, you can do that too. It does not matter to me. As long as you have satisfied all the requirements, there's many ways to arrange the atoms. So it is possible for 3 people to come up with 3 different answers, and they all be right on Lewis structures. Now this chlorine wants to find this dot needs to find a buddy. I'm going to buddy it up here. This one, don't forget your extra double dots around the outside here. And then we've got fluorine, single, double, 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 double. There we go. Let's pair those up. The single dot. And notice it doesn't matter if I put the single dot on here or if I put it on top and then the double dots. It doesn't matter how you twist it or rotate it around the atom. And then we pair it up. Make sure that the single dots on the ends become the line. I even recommend erasing it or even redrawing the whole thing. So now that I know the basic structure, I can quickly draw the ClF F, Cl, and then I've got all the dots to put back on here. Oh, I almost forgot the nitrogen. The common double dots, people forget the nitrogen double dots and the oxygen double dots more often than any other element I've found. So this would be my final answer. I double check, count the atoms or the electrons, do they add up to 38? So I'll do the bonds first. 2, 4, 6, 8, 10. That should be a double dot there. 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38. So that adds up. I would say this is good. Make it nice and clean like this as well. So I'm going to go a little bit quicker here. On this one, carbon has 4 times 2 of them. Hydrogen has 1 times 2. And fluorine has 7 times 2 of them. So I'm multiplying by 2 because there are 2's here. This gives me 8, 2, and 14. 8 plus 2 is 10, plus 14 is 24 is my magic number. Now carbon always goes in the middle, and there's 2 of them. So I said if you have like more than 1 nitrogen or more than 1 carbon, I would recommend stringing them together right away. Give them a bond right away. Now as you get better too, you might even draw the single dots later. So notice I already put a bond here. There should have been a single dot on each end of this, but I knew that I was going to make a bond, so I didn't even bother drawing the dots. But I know that it has 3 extra dots after drawing that line on each one. So my carbons are gone. Now I've got 2 hydrogens and 2 fluorines. They each like to form 1 bond. So let's just start by putting a dot here, connecting it. Let's make it symmetric. Dot and connect. So now my hydrogens are gone. Let's add my fluorines. I'll just put my fluorines here. 1, 2, 3, 4, 5, 6, 7 valence electrons. Connect it. Make it symmetric. 1, 2, 3, 4, 5, 6, 7. Connect it. Now at this point though, we've got a problem. I've used 2 carbons, 2 hydrogens, 2 fluorines. I've used all of the atoms that are available to me, but I have 2 single dots left over. So if this happens to you, after you get done putting on all of your atoms and you have single dots left over, you're going to know that you need a double bond somewhere. And then what can happen is that these 2 carbons have already shared each a single dot. They can share a second set of single dots to form a double bond. But we never ever draw it like this. This looks absolutely terrible. So if you want to piece it together, the puzzle like this first, that's fine. Just make sure you take the time to redraw it. And the common way to draw a double bond is just 2 parallel lines between. You never see, no one would ever draw it like that. Don't do that. So it's fine if you're like doing a rough sketch. I highly encourage it. But then just take the time to either erase the 2 lines and then redraw them neat like this, or just fully redraw the compound. Take time to do that, and then we add all our dots to the fluorine. And then this would be my final compound. I double check 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and that adds up to my magic number. Alright, so now that we're done with that one, we will move on to the next example. Here's our last example for this video. I would recommend pausing and giving it a shot. This one's a little bit more involved, but try it, and if you get stuck, then come watch the video. But if you just watch me, you're not going to get nearly as much as if you attempt this yourself first. So take time, pause it. Okay, and hopefully you're back now. And if you've given it a shot. So we'll start. Carbon has 4 times 3 of them, so times 3. Oxygen 6 times 2, and hydrogen 1 times 4. So this comes out to 12, 12, and 4, 24, 28. And again, always an even number. That is a 28 there. Carbon always goes in the middle, and there's 3 of them. So my advice is just connect them right away. Now carbon likes to form 4 bonds. This one only has 1, so that means it's going to have 3 dots left over. This carbon though has 2 bonds, 1 on each side. So it has 2 dots left over. This carbon has 3 bonds. And if you want, you can always put all 4 dots around each carbon and then go from there. But I'm guessing as you get better, you'll just start skipping that step, and that's fine. Okay, now oxygen likes to form 2 bonds. So it goes 4 bonds, 2 bonds, 1 bond. So we've put these on. I would recommend going with this one next. Let's make this symmetric and just put the oxygens on each end. Because we know hydrogens are dead-end atoms, so we don't want to put the hydrogens on the end. Let's take oxygen. Let's go 1, 2, 3, 4, 5. Let's go 6. So let's leave this bond ready to, or this dot ready to bond with this one. Let's do the same thing on this side. Make it symmetric. Okay, so now at this point, let's just leave single bonds for now, but you'll quickly recognize a problem. I've got 1, 2, 3, 4, 5, 6, 7, 8. I have 8 single dots, and I only have 4 hydrogens left to put on there, and each hydrogen only forms 1 bond. So I only got enough hydrogens to occupy 4 of these single dots. So I'm going to need double bonds somewhere. Now it really doesn't make a difference. You could choose to double bond between the carbons. You could choose to double bond the oxygen to the carbon on the end. Either option is fine. Let's just take a second and double bond this one right here. So I'm going to go with these. And again, this is the rough sketch. That gives me now 1, 2, 3, 4, 5, 6. Well, I only have 4, so let's double bond this one too. I only have 4 hydrogens. So now if I double bond this and this, now I have 1, 2, 3, 4 single dots. Now I can take my hydrogens, and I've got enough hydrogens to fill all these. At this point, I have no single dots left. I have the double dots on oxygen, which remember I mentioned earlier in the last video that these 2 pairs of double dots on the oxygens, they're the most forgotten lone pairs to be written down on tests. A lot of people forget to put those on, a lot of students. Okay, so this is a sloppy picture, so I'm going to redraw this neat. So I would redraw it double bond O, and then I've got hydrogen, 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 and hydrogen, and then don't forget 1, 2, and you can even put the dots like that. That's typically how they're drawn when they're double bonded. So this would be a much cleaner, if I make that hydrogen a little better, this would be a good final answer. You can also, like I said, if you did this as an answer, if you happen to do this, this is an equally valid Lewis structure. This would be equally valid as an answer because all the single dots are used up, all the bonding electrons are used up, all the lone pairs, the double dots are left there. And it doesn't matter either if you put the hydrogen on top of this carbon or the hydrogen below it. That wouldn't make a difference either. And double check too when you do this. If I count, there's 1, 2, 3, 4 bonds, 1, 2, 3, 4 bonds around each carbon. It's very easy to start just accidentally adding on extra bonds, and then I recognize right away if I see this, there's 5 bonds. I know right away that this is an incorrect Lewis structure if I see that. So every carbon should have 4 bonds, every oxygen should have 2, hydrogen has 1. So make sure all the atoms in your structure have their appropriate number of bonds when you are done. So those are just some other extra things to check.